Assalamualaikum warahmatullahi wabarakatuh. First of all, let's say thanks to Allah because of His blessing we can stay here without any obstacle. Secondly, peace and solution might be upon our Prophet Muhammad. Let's introduce our group. We are from Group D. I'm a moderator and we will present about eddy currents. Furthermore, for the first speaker is Kolbi Aulia Rahman as moderator. Therefore, before we start our present, be reciting basmalah together. Bismillahirrahmanirrahim. For the first speaker is Maya is yours.
Eddy currents. When bulk pieces of conductor are subject to changing magnetic flux, induced currents are produced in them. However, their flow pattern resembles swirling eddies in water. This effect was discovered by physicists Foucault, and this current and called eddy currents. Magnetic poles associated with the plane keep on changing as the plate moves in and out of the region between magnetic poles. The flux change induces eddy current in the plate. Direction of eddy currents are opposite when the plate swings into the region between the poles and when it swings out of the region. Note that magnetic moment of the induced current, or which oppose the motion, depend upon the area enclosed by the currents. Recall equation M is A in chapter 4. This fact is helpful in reducing eddy currents in the metallic cores of transformers, electric motors, and other such devices in which a coil is to be found over metallic core. Eddy currents are undesirable since they heat up the core and dissipate electrical energy. In the form of heat, eddy currents are minimized by using lamination of metal to make a metal core. The lamination are separated by an insulation material like lacquer. The plane of the lamination must be arranged parallel to the magnetic field, so they cut across the eddy current path. The arrangement thus the strength of the eddy currents, since the dissipation of electrical energy into heat depends on the square of the strength of electric current. Heat loss is substantially reduced. Thank you.
Next. Olive.
Eddy currents are used to advantage in the certain application like 1. Magnetic braking in trains. Strong electromagnets are situated above the rails in some electrically powered trains. When the electromagnets are activated, the eddy currents induced in the rails of the motion of the train. As there are no mechanical linkages, the braking effect is smooth. 2. Electromagnetic damping. Certain Galvanometer have a fixed core mode of a non-magnetic metallic material. When the coil oscillates, the eddy current generated in the core of the machine and bring the coil to rest quickly. 3. Induction furnace. Induction furnace can be used to produce high temperatures and can be until to prepare alloys. By melting the constituent metals, a high-frequency alternating current is passed through a coil which surrounds the metals to be melted. The eddy currents generator in the metals produce high temperatures sufficient to melt it. 4. Electrical power meters. The semi-metal used in the electric power meters, analog type, rods due to the eddy currents. Electric currents are induced in the disc by magnetic field produced by sinusoidally varying currents in a coil. You can uh, you can absorb the rotating semi-disc in the power meter of your house.
Next, Pramudia.
Mm, Mutual inductance. When a current left is set up through S2 intensron set up a magnetic flux through S1. Let us do not by one the corresponding flux line act with solenoid S1 is N1 P1 some M12 I2 for test simple coaxial solenoids. It is possible to calculate M12 the magnetic field due to current 12 in S2 in the O and to one to left the roosting flux in like egg with call is and one piece one and one L E R two one O and two I will that is total number of students learn as one tune from X nine nine 6, 9, and AQ 9, 10, M 12, and V2 and 2A. We now consider the first cause are current pesatroc solenoid S1 and the flux like the flux to the current is like cause can be assumed to be confined solely in set S1 since the solenoid are filling long. Thus, flux line act with solenoid S to S.
Next, Pavel Pedro Costa.
For the simple coaxial solenoid, it's possible to calculate M12, the magnetic field, do the current I2 in S2 is the resulting in flux link with coil S1 is N1 N L P R quadrat, where N1 is the total number of turns in solenoid S1. Thus form a quest 6.9 and X 6.10. When N2I is the total number of turns of S2, form X 6.12 M21. 21 6.13 using X 6.11 and X 6.12. We get M12 is M21 is M say.
Next.
Outer circular coil. The field at the center of the coil is B2. Since the other so actually placed coil has a very small radius, may be considered constant over its cross-sectional area. Hence, note that we calculate from an approximate value of assuming the magnetic field to be uniform over the area of a fairway can
Our present about eddy current. Nevertheless, before we closing by reciting hamdalah together. Alhamdulillahirabbil alamin. Thank you very much for your great attention, ladies and gentlemen. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam warahmatullahi wabarakatuh.
Bye bye.